right? Right, so the first thing we're going to do is a reflection in the line y equals to x. And this here are the instructions. All you need to do is switch the values of x and y. The x jumps into the y position and the y jumps into the other position. So this is the answer for the first question. Right, and keep in mind y equals to x is a special graph in maths and it always slants upwards. Right, please do not mix up y equals to x with y is equal to minus x. I will be doing this one soon. Y equals to minus x is a different graph to y equals to positive x. Okay. Right, so here's the next thing now, right? There are two ways to do the same exact question. This is the same exact question and nothing has changed. But the first method, do you all find the first method, the one we just described, on a scale of 1 to 10, how difficult do you think that was? 1 being the easiest, 10 being the hardest. What do you all think about the difficulty of that? It's not difficult at all. So I'm just saying, if the examiner were to ask me to reflect something in the line y equal to x, and he didn't tell me which method to use, you could bet all your money I'm going to use the first method. I'm going to use the first method. But remember last week, I had informed you all, right, that sometimes the examiner could tell you to use the matrix method. So if you look back in your notes, how much of you all could see this formula? Look back in your notes. A reflection in the line y equals to x. It's the matrix 0, 1, 1, 0. Just don't say yes, you remember it in your notes. Turn back in your notes, right? And see if you could physically identify that formula. It will help you remember it, right? It's always good to know how your notes are organized, okay? Now, when you found it, let me know. Say you found it. Right? Always know, right? And guys, stop raising your hands in class, right? It distracts me. All right. So I'm just going to do one for you, right? So just to refresh your memory. Let's say the examiner or your teacher says, hey, you have to use that matrix. Let's do point C. Remember the answer for point C using the shortcut method. Remember, C was minus 8, 4. When you reflect it in the line y is equal to x, the answer we got previously was 4 minus 8. We just switched the positions of x and y. I want you all to prove to yourself that you will get the same answer using the matrix. So we're going to take the matrix, which is 0, 1, 1, 0, which you have to memorize for the exam. And you have to multiply it by point C. Remember, when it's time to multiply it by point C, this is x and this is y. The x value goes on top, the y value goes underneath. I want you all to multiply this out. You just don't see you will get the same answer. Let the 4 swing up to the top and you do the full calculation and prove to yourself that you will actually get 4 minus 8. Prove it to yourself. When you prove something to yourself, it sticks in your head and you understand it better. So go ahead, do the calculation. And of course, everyone should be pros now at multiplying matrices because that was part of the homework. I'm pretty sure some of you all won't mind a little refresher, right? Small refresher. So remember, the 4 here swings up to the top, right? Oh, that's a bad color. Yeah, 4, right? So the minus 8 and 4 will walk across. Let me get a different color here. Sorry there. Right. So the minus 8 and the 4 walk across. So minus 8 and 4, and the minus 8 and 4 also get photocopied downstairs. You multiply each pair, you multiply, right? So let's see, I'm gonna get green here. Minus 8 by 0 is 0. Well, anything multiplied by 0 is 0. 4 by 1 is 4. 1 by minus 8 is minus 8. 0 by 4 is 0. To get the answer on top, you add the two values on top. 0 plus 4 is 4. To get the answer underneath, minus 8 plus 0 is minus 8. So when you write back this horizontal, the 4 is the x. The one on top is always the x, and the one underneath is always the y. Didn't we get the same answer? But obviously that's more time consuming, and you only do that if the examiner says, hey, you must use the matrices. All right, so let's move on from this one, right? Let's move on. Easy stuff. All right, so today we're gonna meet the next ghost. Remember last week's ghost was Santiago, and we had heard this whole story about how he lived and how he died and whatnot. So this ghost here has a precious item. Remember, I told you each ghost clings on to a special item that they found very valuable when they were alive. So let's see about this ghost. So the name of this ghost is who? You walk for a few hours in the cemetery and you see someone holding a glass bottle. Her name is Elizabeth, and she was born in the year 1666. Anybody wants to take a guess of why that bottle is so precious to her? I'd like to hear the students guess. What makes that so precious to her? Take a guess and let's see. Sahaman, good. Someone says it's a map, right? Someone says probably from her husband, a note from her husband. Somebody says it's a message from SpongeBob. All right, guys. So later on today, we're gonna explore the whole life of Elizabeth, and we'll see why that bottle was so important to her. So here's the other one, right? You all notice that this line is the opposite now. This line, the mirror is going the other way. And last week I had shown you the graph y is equal to minus x. Minus x just slopes downwards. And I'm pretty sure if you look back in your notes, you will see that. Now, if someone were to ask you to reflect something in the line y is equal to minus x, look at the instructions. The values of x and y coordinates are switched. And you're not only switching them, but the signs become the opposite. So let me show you that with an example. Right now, point A, look at point A. Point A is quite down here. Let me write it. Point A is minus 6 minus 2. Whenever you reflect it in the line y is equal to minus x, look at what happens. You're not only switching x and y, right? The minus 2 will jump here, and the minus 6 will jump here. But after you switch it, you have to make them the opposite. So what's the opposite of minus 2? The opposite of minus 2 is positive 2. And what's the opposite of minus 6? Positive 6. So that means it will end up somewhere here. 2, 6. This is where point E will end up. 2, 6. Let me do another one for you. Point B right now. Point B is how much? Minus 2 minus 2. So when it gets reflected in this line, it becomes, B prime. Well, with this one, when you switch the positions, it won't look different, right? Because both of them is minus 2. But after you switch them, you have to make each one the opposite. The opposite of minus 2 is positive 2. The opposite of minus 2 is positive 2. So that point will end up where? At 2 and 2. You think you all could do C for me? Well, what's going to happen with C? Send the answer there. You put a prime over here, right? Remember, prime just means the new point, A prime. Right? So this tells you A change into A prime. B change into B prime after the reflection. So C is minus 2 minus 4. Well, what do you think the answer for C prime will be? Right, looking at all the answers. Nope, somebody had it wrong. Somebody, oh good, I missed the name, but somebody had it wrong. Remember, you're switching X and Y, but some people forget, and after you do the switch, you make all the signs the opposite. Right? So minus 4 will go here and minus 2 will go here, but then you have to make each one the opposite. My opposite of minus 4 is positive 4. The opposite of minus 2 is positive 2. So that will end up where? At 4, 2. 4 on the X and 2 on the Y. And when you connect this up, this will be the reflection. Easy, right? Once you remember the note. So take down everything I'm circling here. You're taking down this and you're taking down this. So when they ask you to reflect something in the line Y is equal to minus X, do not mix it up with positive X. You switch X and Y and you make each one the opposite afterwards. Right? Don't worry, I think we have another eventually we're going to practice all of these things, and we're going to practice all of them. Whenever you're reflecting something about the origin, the mirror, it's a kind of make-believe mirror. You just have to believe that you have a mirror at the center of the graph, at the origin. And this little point, right, is the mirror. So the mirror in this case here is not a line. The mirror is not a line. The mirror is a point. Okay, great. It's a kind of weird situation, right? So according to the instructions, the X and Y remain in the same position, right? So the X and Y do already switch. You just make each one the opposite. So the minus 4, look for point C. The minus 4 will become positive 4. And positive 4 will become minus 4. Let's do point B. If you reflect it through the origin, the minus 2 and the 4 stay in the same position. Minus 2 becomes positive 2. And the positive 4 becomes minus 4. Each point is becoming the opposite, but not moving. Minus 2 becomes positive 2. Positive 1 becomes minus 1. How much people got all three correct? Let me plot these points. A is 2 minus 1. This is point A, sorry, A prime. B prime is 2 minus 4. 1 second. Right? 2 minus 4, that's B prime. And C is 4 minus 4. Quite down here. So this is how your reflection will look through the origin. Right? Or if you want, you could take each point and multiply by this matrix. Minus 1, 0, 0, minus 1. Okay? If you are feeling adventurous, I would only use the matrix method if I am given no choice. But once I have a choice, I use the easy method. Right? Right, so this one is easy too, right? Once you remember the note. So everyone take down the note, right? I didn't give this, I didn't write it. This is a reflection through the origin. And there are two ways to do a reflection through the origin. You can use the matrix, or you can use the simple set of instructions in bright green. So everyone take down everything I circle. To the top of your page, you put in reflection through the origin and the two methods you could use. Obviously, this takes a lot of practice, right? Obviously, I can't get this and memorize everything in one shot, right? It will take a lot of past paper questions. It will take me repeating it over and over as class goes along. And it will take you also revising and doing the homework to memorize it, okay? But it will get easier like anything in life once you practice it and you're doing it all the time. Right? Let me know when you're finished. We will be moving on. All right, so here's what happens to Elizabeth. So English, you all know what it means to maroon someone? Do you all know what it means to maroon someone? For those who watch movies and read books, what does maroon someone mean? Right, so when you maroon someone, and a lot of sailors used to do this to other sailors, right? They would find a rock and just put the person on the rock and sail away. The person really has no way to escape from the rock. So they slowly die of thirst and starvation. Okay? So this is what they did to Elizabeth. I don't know if you all think she's deserving of it. I mean, she was a pirate, right? She probably deserved such a fate. You all could decide for yourself. So once she was on this island, right, she lost all hope. But then one day, while on the island, a bottle came floating in the water. So she grabbed the bottle, right? The message was from a shipwrecked sailor. So there was another sailor somewhere around on a different island who was also stranded. And he was throwing bottles with messages in the ocean. And one just happened to reach Elizabeth. So Elizabeth got some hope, right? So she began to swim in the direction she thought the sailor was stranded on, right? So everyone okay so far with the storyline? All right. So this one here, here's what I need for you all to do. Before I attempt this question, right? I want you to take down everything here. We are going to do something called an enlargement. So the name of this topic is an enlargement. Okay? Take down this note. There's no need to draw the graph, and I will explain everything. Okay. So here we have a triangle. Let's say that we want to enlarge it by a factor of 3. So you want to enlarge it by a factor of 3. What does that mean? I mean, obviously, if you're enlarging something by 3, that means the triangle should be how much times bigger at the end of the question? 3 times larger. Okay? And of course, when we finish draw the final triangle, we can actually prove to ourselves, right? We can actually prove to ourselves that the triangle is 3 times larger. All right? Great. So here's what we're going to do. I think I animated this one. Well, what you have to do, for the time being, we are doing an enlargement. I'll read the question properly in the exam. An enlargement from the origin, which means that if they ask you to enlarge something and they use the word origin, you have to pretend that you're standing up at the origin. We all know where the origin is. The origin is where the X and the Y axis meet. Okay, great. So what you have to do is take your ruler in the exam. And the good thing about these questions, the examiner will draw the graph for you already and draw the original triangle for you. So in other words, when you open your test papers, you will see this entire thing here already drawn up on graph paper for you. You just have to make it 3 times larger using the appropriate technique. Okay, so here's what you're going to do. From the origin, you're going to draw a line to one of the points. You can start with any one of the points. You can start with A, you can start with B, or you can start with C. Okay, I'm going to start with B first. So you're going to take your ruler in the exam and draw a line from the origin to point B. Okay, what you are going to do after, you have to measure the length of this line. So in the exam, let's say you measure this line and the length is 7 centimeters from here to here. You have to extend this by a factor of 3. Now, let me show you what to do. Using your ruler, you're going to extend the line and make it 3 times larger. So you extend it another 7 centimeters and you extend it another 7 centimeters. Do you all think we have to go a third 7 centimeters, or is this a factor of 3 already? Well, what do you all think? Do you all think we have to go one more? Like, for example, the first line, right? And a lot of people get this wrong. I used to get it wrong in school too, so I understand. This is why I'm spending so much time on this one. You see the first line that you drew counts as 1. And a lot of people don't count the first line. I don't know why I didn't count the first line in school. And you see the second time you extend it, the next 7 centimeters, that's the second time. And then the third time, the next 7 centimeters is the third one. That makes how much? The factor of how much? 3 in all. You see, some people will go 1 extra line here because they forgot to count the first one. So instead of extending it by 3, they ended up enlarging it by 4 by mistake, right? So you have to be really, really careful about that. The first line that you draw from the origin to the point counts as 1. So in other words, I just say, if they had asked you to enlarge it by a factor of 2, if the first 7 centimeters would be 1 and the next 7 centimeters would be 2, that would, and I would stop the question there, right? But this one is 3. So let's go ahead. Guess what you guys have to do now? You have to do the same thing for point C and A. So watch me animate it, right? So I will take my ruler and from the origin, I will connect it to point C. You all see the short blue line here? Let's assume that's 2 centimeters. We have to extend it how much more times on the chart? The first line, and how much more times do we have to extend that 2 centimeters? 3 more times or 2 more times? 2 more times, correct. So we're going to do it slow, right? 1, 2. So how long do you think this entire blue line would be? The entire blue line. If the first portion, I'm just saying, if the first portion was 2 centimeters, the whole thing would be 6 centimeters. Okay? Are we going to do the same thing for point A? Take your ruler from the origin to point A, you draw a line. Let's say, I'm just saying, let's just say that green line was 5 centimeters. Then you have to extend that 5 centimeters 1 more time. That's 10 centimeters. And then 1 more time. And it becomes what? 15 centimeters. All right? So that means point A becomes how much? Let's look at the coordinates. 3, 9. B prime becomes 3, 3. Look at it, it's 3, 3. And who is this? This would be, no, this is C prime. My mistake. Some people are correcting me already. Good, good, good. This is C prime. And this one up here, remember he was B and B got stretched over here. B prime. He is 12, 6. And if you connect it, and it's going to look something like this. What do you all think? You think it will look something like that? All right. So I think I have a better drawing of it. Let me show you the better drawing. Won't it look exactly like that with forget the prime, A prime. Now, I know somebody is telling me something, and they have a point, right? You all notice all the points just got multiplied by 3 when it's an enlargement of 3. For example, look at point B. Point B was 4, 2. If you multiply both points by 3, like the 4 by 3 and the 2 by 3, won't you get 12, 6? Won't you get 12, 6? Right? Look at point C. C was 1, 1. When you multiply all of those points by 3, because it's an enlargement factor of 3, you get 3, 3, because 1 by 3 is 3. And the same thing for point A. If you take point A and you multiply everybody by 3, you get what? 3 and 9. But here's the thing, right? That multiplying it by 3 only works if the center of enlargement is the origin. And this is real important. And you think about it, and you're going to see a question today that whenever the center of enlargement is not the origin, like for example, if I told you the center of enlargement was this point, who is not the origin, multiplying everybody by 3 simply would not work. Only the drawing method would work. Also, the examiner could tell you do it using the drawing method. So even though you know if it's an enlargement through the origin, even though you know that multiplying all the points by 3 would give you the same answer, if the examiner asks you to use the drawing method, guess what? You have to use the drawing method, which means you have to draw the lines and extend it by how much other times. Now, a few people want me to do it over again. Not a problem. Okay? I'll do this one. I'll do this one over. I have no problem. Right? So let me go back here a little bit. Right? Let me go back here. Right. So I'm taking off the recording because I don't want it to be recorded twice, right? Gotcha. What you want to do is choose one of the sides of the triangle. Let's choose the vertical side, right? This side is how much blocks long. How much blocks is this side of the triangle? 1, 2. You all see 2 blocks, right? 1, 2, right? The new side, how much blocks is it? 1, 2, 3, 4, 5, 6. How much? It didn't get 3 times larger. It isn't 6 3 times larger than 2. So you just need to test run one of the sides, right? And you just have to show and prove to yourself that, hey, the sides did get 3 times longer. All right. Great. Now, there is a matrix way of doing this, but the matrix way only works if they ask you to enlarge something and you're doing it from the origin. The examiner has to use the word origin. I want you all to look back in your notes. See if there's something called an enlargement matrix from your notes from last week, and send the matrix on the chat. Look in your notes from last week. I gave you something called an enlargement matrix. Look real carefully. Right? You can't miss it. You can't miss it. So we're going to go to that just now, right? Let's continue the story. Remember, Elizabeth came off the island, right? She began to swim, hoping that she would find this stranded sailor who is on our next island. And she did make it to an island with the sailor. So this is the sailor here. This is Elizabeth, who now washed up on the shore. She probably is exhausted because that's a long swim, right? Right, so the name of the sailor was Captain Fletcher. Anybody knows where this name is from? Hey, this is actually a real name from history. Fletcher Christian. And that sounds familiar for those who read books and things, like you're real into books and I guess some movies and things. Who is Fletcher Christian? Come on, guys. Some of you all may have read. This is from a classic book, like how Robin Hood is a classic book. This name is from a very classic book and also a true story. You all never heard about this this thing called the HMS Bounty? Your parents never made you read this book as a kid? The mutiny on the HMS Bounty. All right, for those who never read that book, it's based on a real story in history where there was a mutiny on a boat, and the captain and some of his crewmates, they threw them off the boat, and the name of the boat was what? The HMS Bounty. And one of the guys who led the mutiny, his name was actually, I reversed the name. His name was Christian Fletcher. I just put Fletcher Christian. So for those who are interested in reading up about it, you can read it. It's a really great book. You will love that book from beginning to end. Anyway, so let's move on, right? So we'll see what happens between Elizabeth and Mr. Fletcher Christian here. Oh, we have a little storyline here. So apparently no help ever came to rescue the two of them, and they spent 28 years on the island together. But something bad is about to happen after the 28 years. So I don't know if you all are able to predict what bad thing is about to happen. All right, so this one here, let's say, and I want you all to do this the matrix way now. I have another question. So the exam, you open the exam paper, and the examiner says, you have to enlarge the triangle, right, by a factor of how much? 2. But he wants you to use the matrix method, And you notice the examiner was real nice in this one. He said the center of enlargement is the origin. This formula only works if the center of enlargement is the origin. So the examiner has to use the word origin. If the center of enlargement is not the origin, please do not use this formula. If the center of enlargement is not the origin, you have no choice but to use the draw-in method. So here's how you use this formula. How much times do they want you to enlarge it? By a factor of 2. So you see in the formula, you replace the letter K with 2, as simple as that. So both K's, you replace it with 2. If they wanted you to enlarge it by a factor of 5, you would have replaced both K's with 5. And the formula will always have 0 here and 0 here. And all you have to do is take this matrix and multiply it by each point. Let's start with point A. Isn't A 1 minus 2? You put the 1 on top and the minus 2 underneath. The X always goes on top. The Y goes underneath. You think you all could do this calculation for me and tell me what you get for A prime? This is A. And when you take this matrix and you multiply by A, you are going to get A prime. Right. K doesn't mean constant. K just means the value you are making it larger by, right? K for constant is in physics. This is not physics. This is just maths. And the truth is, you can use any letter here. If you go in our next textbook, they mightn't have the letter K. They might have P or E or something like that, right? K is just the value you are making it larger by, okay? Multiply it out, right? So you're going to realize as class goes along, I'm going to stop doing the multiplication of the matrices, because multiplication of matrices, we did it last week. You had a whole set of it to do for homework. So after a while, I'll just be putting down the answers for the multiplication, right? To save time in the exam. What did you all get? When you took that matrix and you multiplied it by point A, what did you all get for A prime? Did you all get 2 minus 4? You realize the points just got twice as large, right? You took, but I know what you're saying, don't do that in the exam and look and just put down the answers. If the examiner asks you to use the matrix method, you have to show him the entire calculation, even though you know at the end of the day, the points just getting multiplied by 2. You're getting marks for your working, right? You forget how they're working, you're going to lose marks. Unfortunately, guys. All right, so sorry to burst a little bubble there. So A becomes 2 minus 4. So A prime is 2 minus 4. Right? And guess what you have to do? You have to take this and do it for, right? So you're going to take this matrix now again and multiply it by point B. You think you all could do it for point B? Point B is what? 3 minus 2. And then you do it for what? Point C. So finish it off for me there. I know some of you are just going to multiply each point by 2 to save time. But for those who really want to practice multiplying matrices, feel free. Right? So I'm going to give everyone 2 minutes to do all the calculations and send the answers. All right, so when you did your calculations, you'll see the answers for B prime here, for C prime. And when you plot the points, you'll notice the triangle look twice as large. And I can prove it's twice as large. Let's take this side here. This side is 1, 2 blocks. And our answer is 1, 2, 3, 4. So we saw that one side at least got twice as large, because 4, is twice as large as 2. All right, so how much people got everything correct there? Like no errors whatsoever. Right, great. And a lot of people are saying it's easy. I'm glad you find it easy, right? So, well, someone asks why we don't have to draw lines, because the examiner, remember, I am taking the role of the examiner, and I am telling you that you have to use the matrix method. Don't get me wrong. If you use the drawing method, look at this, guys. If here's the origin, and I draw a line from the origin to B, let's say I want to use the drawing method. Quick question, if I use the drawing method, would I get the same answer? Or what do you all think? If I use the drawing method, I will, right? For the drawing method, if I connect it from the origin to point B, let's just say that this line is 8 centimeters. I don't have a ruler here. How much more times would I have to extend it by? Do I have to do 1 more 8 centimeters or 2 more 8 centimeters? 1 more, right? Because the enlargement factor is 2. Look at it here. The question said 2. Okay? So that means the first line counts as 1, and then I have to enlarge it or extend the line by 1 more 8 centimeters, making it 2 extensions in all. And I have to do that for all the points. From A, I extend it once and 1 more time. And then for point C, 1, and whatever the length of this line is, I extend it by that length 1 more time to make it 2 in all. Keep in mind that these methods, well, this matrix here only works if the center of enlargement is the origin. Okay? All right, so I hope that answers some of the questions. That's the best I could do right now. Let's move on. All right, so we're coming close to the end of our, well, what do you all think is going to happen here? Remember, Elizabeth and Christian have a family now on this stranded island. What do you think is going to happen? This is a sad ending for the family, but remember, it's a horror story. So the sea retracts, right? So you all know about that. When a tsunami is coming, the sea goes back and the sea slant. Unfortunately, there's a huge wave coming towards them. They cannot avoid it. it comes closer. And unfortunately, that's how Elizabeth met her end. All right. Right, so now you all know why that bottle was so important to her, right? And she's going to give you some information now, right? Remember I told you, you speak to the ghosts because they give you information about crimes that are about to happen and whatnot. So, so yeah, Zion, you technically. All right, guys, so let's move on, right? So this question is a little bit different, right? They want you to enlarge this triangle by a factor of how much? 3, where the center of enlargement is -1, 3. So they want you to make what? This triangle 3 times larger. Anybody can tell me, if I ask you to use the matrix method, anybody can tell me the values that will go into the matrix method, into the matrix? Right? How much people were in? It's K00K, right? So it's 3003. Everybody agrees with that? That's the matrix we have to use. And then we have to multiply each point by this matrix. Like point C, I'll write it bigger, is 3, 1, right? So that means, yeah, for point C, you write it vertical. Point C is 3, 1. If we multiply it by this, well, what do you all think you would get if you multiply it by this matrix? And you're really essentially making each point 3 times larger. So you just really, at the end of the day, right, you will get 9, 3. You're multiplying each point by 3. How much people think I am talking total garbage right now and trying to fool you? What am I? I'm trying to fool you guys here. Only a few people said, no, sir, you're doing it the wrong way. Anybody wanted to stop me here and tell me what am I doing wrong on purpose? What am I doing wrong? Well, what am I trying to trick you with? Right. Right. So I'm glad some of you all are seeing it. Is the center of enlargement the origin? Are we pretending over here is the center of enlargement? No, this formula only works. And if you look at the notes, it only works if the center of enlargement is the origin. And it's not the origin. So we cannot use that matrix. So what's the only way to get out this question? If we cannot use the matrix, which method are we forced to use now? The drawing method. I'm glad you all saw this, right? So it is the drawing method, okay? Great. So what we have to do, keep your eyes on the center of enlargement. The center of enlargement, look at it here. I'll underline it, is -1, 3. It's kind of hard to see, but I'll darken it here. It's the point P over here. You all notice that's the point -1, 3. So you have to pretend all your lines are coming from that particular point, not the origin this time. So it's almost the same drawing method now, but instead of drawing from the origin, you're drawing everything from point P. And it's a factor of 3, so I'm going to animate it for you guys here. From point P, we're going to draw a line from P. You all notice we made each line 3 times larger. Look at this. It's kind of hard to see here. This line from here to here. Let's say this line was 7 centimeters. What would be the length of the entire line up to here? Anybody wants to take a guess? What would be the entire length of the line if we were to extend it 3 times? It would be 21, right? Because the first line counts as 1, the next extension counts as 2, and the next one counts as what? 3, because it's an enlargement factor of 3. And I did that for all the lines. From point P, I drew a line to 1 point, and then extended it 2 more times to make it 3 in all. Because the first extension, the first line counts as 1. And we did it for point A as well. From P to A, whatever length that was, I did it 2 more times. And look at this. Let's see what the triangle will look like. When you connect all the points, you will get that triangle. Did the triangle actually get 3 times larger? You all want to take a test side? Take one side of the triangle and compare it to the new triangle and ask yourself, did it get 3 times larger? It did. Okay? It did. I will take the vertical side, because this side is 1 block high. And look at it. This is 1, 2, 3. All right. And someone asks how we got P. P will be given to you by the examiner. Look at the question here. They said the center of enlargement is -1, 3. So this point P is -1, 3. I plot that point on the graph. Or the examiner might already put the dot for you and say that is the center of enlargement. All right. So that is how I got the -1, 3. It was given to you in the exam, right? Right. Great. So you think you understand this one now. When the center of enlargement is not the origin, you're forced to use the drawing method. Common trick in the exam, real common trick. Okay. Great. All right. What's the time now, right? We still have some time. So let's move on. All right. How easy do you think this question would be? Look at this question. In all the other questions, they gave you the center of enlargement. In this one here, if you wanted to find the center of enlargement, all you have to do is connect 2 similar points and backtrack. Well, before I show it here, let's say you had a bigger triangle here and a smaller triangle here, right? Let me draw one here. To find the center of enlargement, sorry, this is a horrible example here. All we have to do is connect 2 similar points. This is a reverse question. So they already enlarged the triangle for you. They gave you the final answer. And they want to know where all the lines are coming from. Well, what's the point everything is coming from? All you have to do is connect 2 similar points on the triangle, like, and these 2 match up, and didn't this point grow up to become this point? Didn't this point grow up to become this point? And one more. Didn't this point grow up to become this point? All you have to do is backtrack the lines. The pink line continue it backwards, and the blue line continue it backwards. And wherever all 3 lines meet would have been what? The center of enlargement. But let me do that better for you all using some animation here. Here's how you find the center of enlargement, right? You all see what I did? The 2 similar points, I connected it and I extended it backwards to the end of the graph paper. And then I'm going to do the same thing for all the similar points. Look at this. These 2 similar points, I backtrack it. And this one here, I'm going to backtrack it. All the lines came together at this point. What's the coordinates of that point? 4, 5. 4 on the X, 5 on the Y. So the center of enlargement is how much? 4, 5. Anybody wants to tell me how much times larger the triangle got? Even though they didn't ask that question. But how much times did the triangle got enlarged by? Well, what was the factor? It was 2, eh? Yeah, because if you take this side, the horizontal side is how much blocks long? 1, 2. And over here it's 1, 2, 3, 4. So it went from 2 to 4. It got twice as large, right? Right, so when I ask you to find the center of enlargement, to me, that's one of the easiest questions in this topic. You connect these similar points and you backtrack it and you see where all the lines are kind of like coming from. Okay, so that's a reverse question. You're going to get a lot of practice on this when we start the past papers, right? So just keep it in the back of your head, right? All right, so look at the next ghost now. We have a next ghost over here. What's this ghost name? I can't find her name. What's her name? What's her name? My head getting a little dizzy here. Getting tired. You're going to be using a ruler to draw the line, right? For those who are asking, you can't draw a line. You use a ruler to draw. All right, her name is Jenny, right? Look at there. I don't know how I missed that. So Jenny was born in the year 1477, and her most precious item in life was cheese. Anybody want to take a guess on that? Why cheese was so important to her? Again, this triangle is a result of enlarging a particular triangle by 2. Do we have the original triangle? Now, let me ask that question first. Do we have the original triangle? The answer is no. Isn't that your job? Your job is to find that original triangle and keep in mind that it got enlarged by a factor of 2. So here's what you have to do in this question. You're going to take all the points and connect it back to the center of enlargement. So watch me do this. So you see all the points, one by one, I am going to connect it to the center of enlargement. If the enlargement is a factor of 2, if we were doing it in a forward direction, won't we have to extend the line by 1 and then extend it one more time? Like, for example, if the first extension to the original triangle was 8 centimeters, won't the next extension be another 8 centimeters, making the total amount of 8 2, making it a factor of 2? All right? Right? Great. So if here's 8 and over here's 8, is it fair to say here's the midpoint? Because if the whole line is 16, if here's 8, the first 8 would be the middle of the line. So do you think it is fair that all of these lines, you're already just dividing it by 2? You're dividing the green line by 2, the blue line by 2, and the red line by 2. Make sure you see that. I'll pause it here. Make sure. I know some of you are having some draw a triangle. Let me erase this. Won't the original triangle look like this? The green line, I divided it by 2. So you have to use your ruler, measure it, and then find the middle of the line. So if the whole length of the line was, let's say, I just say if, right? Let's say the whole length of the green line was 26 centimeters. I just saying if. You would divide it by 2 and get what? 13. So from here to here would be 13, and you put a dot. Then you measure the length of the blue line, and whatever length you get, you divide it by 2. And the same thing for the red line, divided by 2. And then you connect all of those points, and you get your answer. Everybody think they understand it a little bit? If you all want to take if you all want to take a screenshot of this one, because some people are asking to take a screenshot, feel free, right? But there isn't really a note here. This is more, how you say, eventually it will become common sense. Like you're going to be seeing so much questions like this. You're just going to instantly know that, hey, if it's an enlargement by 2, then I'm ready finding the midpoint of the line. Because each side of the line would have, each side of the point, would have the same distance. This side and the other side would be the same distance. All right. I think I have another example after this one, right? So if you're a little lost, give me a chance to do the next one, no? And even so, even if you're still lost next week, I'm gonna make sure and start back from here itself. Okay. All right. So let's see what the next slide holds, right? But the main point is, since it's an enlargement of 2, you're finding the midpoints of the line. Right? So let me see if I have time to do another example. And if I do, right? And if I don't, I will make sure and do it back next week. All right. Oh, I think you're gonna like this one. This one here is not going to be a horror story. All right. So let's see what's going on with Jenny here. By the way, this is Jenny, and this is her friend, the mouse or the rat. Okay. Now read Jenny's story. Right. Oh. Jenny has a unique ability, right? Jenny has a unique ability. She can actually talk to rats. But remember, this is in medieval times. If somebody knows you're talking to rats, they're going to accuse you of what? Being what? A witch, right? So she usually kept that to herself and her parents. She didn't tell anybody else except her parents, right? So this is what the rat is saying to her. Oh, by the way, she could also rap. You all want to hear Jenny rap? So the rat tells her, thanks for the cheese, Jen. How much of you all want to hear her rap? Think she's a good rapper? Who's a good rapper? I don't know much good rappers. Jay-Z's a rapper, right? I don't know who. I don't know much about rap music. So let's hear Jenny respond. Eminem, right? So she's like Eminem. Or Kelly, this Gun Kelly guy. I don't know his name. Whatever. All right. So let's hear Jenny rap. So put on her rapping cap. You can't rap without your cap, right? Get a little beat going here.
No sweat, cheese breath, just don't make me regret. Yo.
All right. How would you all rate that performance? How would you all? I would definitely go to Jenny's concert. What? What's wrong with you all? And that's a 10 out of a 10 performance here. She'll sell out a crowd in no time. All right. All right. I will just take the heat here. All right, guys. Okay, so let me explain this last one. I need to explain this last one, right? Let me say you have to do an enlargement by a factor of 3. Remember in the previous example, it was an enlargement of factor of 2. And since you were enlarging something by a factor of 2, the first line counts as 1, and the second line counts as what? 2. So since both of these lines have the same length, this would be the midpoint. But this one here, I hope this one, for those who were lost on the last one, I hope this would help you fill in the gaps. If it's an enlargement of factor of 3, remember from the first point to over here would be 1. Then you would have to enlarge it one more time. That would be 2. And then since it's an enlargement of factor 3, you go one more time, and that would make it 3. Everyone remembers that, right? When it's an enlargement of factor 3, you have to extend the line so that it's 3 times larger, but the first line counts as 1. So if this was 6 centimeters, and if this has to be another 6 centimeters, and if this has to be another 6 centimeters, everyone agrees that the original triangle is by the arrow, because you go from the center of enlargement to the first point on the triangle. So if you wanted the first point on the triangle, this 6 centimeters is how much of the entire line? Is that half of the line, 1/3 of the line, 1/4 of the entire line? What fraction is the distance from the center of or the center of enlargement to the original triangle? It would be 1/3, right? Because if the whole length is 18 and you only have to go up to 6, then 6 divided by 18 is 1/3. So that means when the center of enlargement is 3, you're going to draw lines and find 1/3 of the length of the line. So let me show you that by animating it. So over here is the center of enlargement. This was given to you by the examiner. It's written on the exam paper, -6,2. So from that point, we are going to draw points from there to the enlarged triangle. The green line, the blue line, and the red line. For the green line, we're going to have to take our ruler. I'm just saying, if I don't have a ruler here. Let's say the entire length of the green line was 12 centimeters. How much is 1/3 of 12? 4 centimeters, right? And 1/3 of 12 is 4. So you would only go 4 centimeters. I'm not too sure where the 4 will be. Let me just assume it's here. So you would measure 4 centimeters because here will be 4, another 4, and eventually another 4, making you 12. So for the blue line, you're going to do the same thing. You're going to measure the length with your ruler, but only find 1/3 of that length. And then you're going to do the same thing for the red line. Measure the length of the red line and find 1/3. Right? I think it might end up here. Not too sure. But let's see what the answer would look like. Ta-da! Yeah, I was correct. Right? And for those who didn't understand the first example, when you were enlarging it by a factor of 2, you would find half the length of the line. If the enlargement is a factor of 3, you find 1/3. If it was an enlargement of factor 4, you would find 1/4. And I think you all get the idea now. Right? The direction of the line is from the center of enlargement towards the larger triangle. So you go from here towards the larger triangle. You think you all understand it a little bit better now? Right? When it's an enlargement of factor 2, basically you're taking the enlargement factor and putting it underneath a 1. So you know whether you're finding half the length of the line to 1/3 the length of the line. All right, so